sentier de gloire, sentier de gloire. Sans son temps, trop vite oublié, effacé. Lumière pour réveiller son enfant tout au long du chemin. Trop vite oublié, effacé. Lumière pour réveiller son enfant.
Yeah, hello guys. So we're going to be talking about building reproducible ML or AI pipelines. So this is going to be about pipelines, but with regards to machine learning, AI, and ML ops. So for context now, basically the goal is to build a retrainable a pipeline that retrains machine learning models automatically. It's automated with all the data science process, and the context is say we have a properties company that they have a model that predicts the price of properties, and they receive fresh data every week. They need to update this model. What we're going to be this project will be about building a pipeline that can retrain the model in the same cadence, end to end with you know with the same other parameters, and it also evaluates the matrix, the results. We use the evaluation matrix to determine how well the model performed, and all that is going to be automated as seen in this diagram. So we're going to be using MLFlow is a pipeline tool for orchestration. uh, we're going to orchestrate the data science steps. Weights and biases is for storing data artifacts, model artifacts. It also stores records of your evaluation metrics, um, and you can share with your teammates. You can board your team, and they get access to this data about the model. Hydra is for configurations, stores your configurations, and Conda is the environment we use. So this this now is what the MLFlow directory looks like. So you have a main file that with Hydra we have all the data science steps. Basic cleaning, data check, data split, training and testing, and we're going to be using Conda. you know yeah, for this we're going to go into the steps now. This is the step. Each there's a file package for each step, and they have their own specific Conda environments requirements. So basically the pipeline creates a Conda environment for each step, and the step is able to run within that environment, and you know drop an output, which another step picks up, and the other step has their own environment. So so this, for example, this is the step in the basic cleaning step. You can see dropping outliers, um, converting you know to date time, as well as training. You can see. So so this here we can see our model is being used. So well, yeah, we're going to cover all this in more details. um so this is weights and biases. You can see, you can invite the teammate to have a look at the different projects you have, and what our project is going to look like is is you see we're going to have like multiple runs, and what the assessments, list charts about each model. We're going to see the runs, and the different outputs from the runs. So this was the previous project. You can see AUC score. Yeah, the evaluation matrix. The evaluation matrix used was AUC score, and yeah. So getting into the process now. So first of all, we want to do like a short. We're going to run maybe first two steps just to see how it is. And to run MLFlow, you simply just MLFlow run. That's after installing it. You have to install MLFlow. So you can either use the MLFlow run, then dot means you're running all the steps, or you can specify which step you want to run. So we're going to run the first two steps just to see. So yeah, the pipeline is done now. If I'm logged into one one 1 dB, so weights and biases going on will refer to as 1 dB. So I've logged into 1 dB with my API key, so that's why the pipeline is able to just log into 1 dB, upload data artifacts, and just to see what the data looks like. uh, so imagine this: you're making a prediction and you need different values that are relevant: host name, neighborhood, latitude, longitude, type, price, minimum nines, number of reviews. So these are the information we're going to use to train the ML model, to retrain the ML model. And so it runs, and we can have a look at the run on 1 dB weights and biases. We're going to just so we can see now 2 minutes ago. So this is what we just ran. So we can go to runs to see that the first two steps took in the raw artifact, outputted clean, and what the artifacts now. These are the artifacts, the raw data, then that is cleaned. You can also tag, maybe you want to tag this reference, because though we'll use it later on. So we want to tag this reference. You can check information about your data artifacts. You can check the lineage. It just shows you the steps so far. Download raw. So so that's for the first two steps. There's also, you can also run like a Jupyter notebook to explore your data. It's a pipeline that you can use to interact. It gives you that flexibility, or to interact with data artifacts. And so we want to run the Jupyter notebook here. You can see. So this is the notebook. Yeah, I just interacted with the data. This is the sample data we just, you know, from 1 dB, and you can run a bit of profiling on that data using Pandas profile library. This is Pandas profile library, and this is what the report looks like. It gives you different statistics about your data, number of variables, missing cells, duplicate rows. You know, can know whether your data is skewed or not. You see, for each field, it gives you that value. And okay, so this is you can see interactions, correlation between the fields, missing values, and yeah, basically that kind of information. You can see it. So okay, let's control C. Okay, so now for this, now we're going to run the full pipeline just to see, the process end to end, how the pipeline is going to run end to end, and I basically apply the configurations as specified, run tests. So we're going to come back to this once it's done. So now it's done, and we can see, first of all, this is a coefficient of determination R squared, and mean absolute error. These are the metrics used to evaluate our model, and you can also see the scores, probably the training, splitting, so we can see the test. This test is for the data, test row count, column names, the expected columns, a proper boundary test. And you see all this was done with MLFlow. MLFlow orchestrated the process from start to finish. And we can take a look at we can see there are more runs now. That's more runs for each step. This is the future importance chart that we uploaded, alongside, as the pipeline, calculated, graphs the future importance for each feature in the data, and then provided that chart, so we can see the full process. There are more runs here now, and so we can even add whatever column that is not there. Add it. So okay, so we're still going to let's go to the model first. You can see the model has been loaded, and this is the model that was trained. This is the trained data, test data. They both have all the same. See the features, max depth, if you are familiar with random forests, you know these parameters. Um, the parameters, you can see the lineage for this random forest model. Just basically you know, illustrates the process that went into generating the model. So um, so eh, we so that we will see the values. If we see that the values are logged, we can tag our model. Yeah, we can tag it as, okay, this one should go to prod. Use this one as prod. So we basically tag it for your teammates to know. And let me uncheck this so that we'll see the test results. um, we'll see the test results specifically. uh, so can even use the the steps. So test regression model. So yeah, now this test regression model step is to to pick, is for the specifically for that prod model. For once you've tagged it as prod, you can run this test regression model to run a test and run this check. This will mean absolute error check and the R square check, so that you have those values. You have those values when you need them. This should be here. Let me okay. So look at it here now. This is what I'm looking for. See, this is what I'm looking for. So it's just to show that value. Show this value that, okay, these values are recorded. You can move them to let's just pin them. Pin this one and pin this one. So you have two of them because these are the two the metrics we are working with. So yeah, and lastly, MLFlow can also store these. It can also store this variable. You know, it stores the different runs, that that the pipeline makes for each step, and you can also use it to store your data artifacts. Different steps, and you know, it doesn't store the actual artifact, but it just stores like metadata. The only difference between this MLFlow, the MLFlow for experimentation and 1DB is you can't share. You need like a central location to give access. Give your team access to this metadata from the runs, which which 1 dB provides, unlike MLFlow. And you know so that's the advantage. That's collaborative workspace. We don't have that with MLFlow. So I think that's pretty much it for this session. I mean, if you have any questions, send a mail, leave a comment. you know yeah, let me give an outro music.